Okay, let's talk about balancing chemical equations. When we look at a simple equation like this, where we combine hydrogen gas and oxygen gas to make liquid water, we are looking at one of the most simple equations that you can really think of in chemistry, because you just have two things put together and creating something that we're pretty familiar with. We call this also a synthesis type of reaction. And in this synthesis reaction, it's important that we remember that everything on the left side has to equal the amount of matter that we end up with on the right. So the reactants must equal the products. So the reactants, what I mean by that is the amount of stuff in the reactant side has to equal the amount of stuff in the product side. So the way that we can check for that is by drawing real quick what the molecules kind of look like here. And I've drawn them just sort of cartoonish like, where you've got hydrogen right here and oxygen right here. And these two different colored double rings represent what hydrogen and oxygen gas look like, because H2 is a bond between two individual hydrogen atoms bound together, and O2 is a bond between two individual oxygen atoms bound together, actually with a double bond. But regardless, the way that we want to check to see if this equation kind of makes sense logically is to look at the number of reactants that I have and the number of products that I have. So right off the bat, you might notice a problem. I start off with 2 over here, 2 over here, and then on the product side, draw a line here, I have only 3 atoms on this side. Where did the other oxygen go? Well, if this was true, it would have disappeared and gone into oblivion. That's not true. That's not how the universe works. It can't just disappear into oblivion. So instead, the way that we think about trying to understand equations is that we need to balance them. And what that means is I have to have the same amount of stuff on one side as I do on the other side. I have to be able to make in my products and conserve how much mass I start with and end up with that same amount of mass on the after the equation has proceeded. So what I want to do is I want to end up with sort of like 4 atoms here, so that 2 plus 2 equals 4, right? I have right now 2 plus 2 equals 3, and that's of course not true. So I need whatever's on this side to add up to what's on this side. That's one kind of quick way to look at balancing equations. The first way to go about this to try to troubleshoot the problem is to see what am I actually missing on the right side, because I can't just add another hydrogen atom like this and assume that if I add that hydrogen atom, it'll all be fine because there's 4 over there. But there would be a problem, right? I'd have 3 hydrogen atoms and just 1 oxygen atom, and I started off with 2 and 2. So I want to end up with 2 and 2. The thing is, I can't do the opposite. I can't put another oxygen atom in there as well. I can't just go ahead and grab an oxygen atom and throw it in over here somewhere and just have it hanging out, because that's not what water is. Water is 1 oxygen and 2 hydrogens. So how do I fix the problem? Well, I can always make a second water molecule. Okay, so I can always make a second water molecule, and that's fine. I can have 2 water molecules, but I have to have enough ingredients to make 2. So I can say that I have 2 molecules of water, and I can put a 2 right there to symbolize that. So there's the first molecule made and the second molecule made. That's fine, but I have to have enough ingredients to make that work. You might notice I have enough oxygen to make that work, right? I only need 1 oxygen molecule in order to make that work, because here goes one of those atoms and here goes the other atom. Okay, so I've got the right representation of oxygens, but I don't have the right representation of the number of hydrogens. I'm missing another hydrogen atom. So what can I do? I can add another hydrogen atom molecule to the reactant side, and now if I put 2 there, I have the right number of things, the right number of atoms, because each of the ones on the left can be found on the part of on the product side on the right. So I have two molecules of hydrogen, and I have one molecule of oxygen, and that can give me 2 molecules of water. This is a balanced equation. Okay, so this is a correctly written and balanced equation, and the way that we know what we're looking for is the proper number of things in front of these symbols for the molecules or the elements, whatever they are. I'm looking for the proper number of things in front. If that number, when you would draw out the actual molecules and count them up, is not true, if I don't have the right number of things on the left side as I do on the right side, I will have to figure out how to make those two things balance. There's always a way to do it as long as the chemical equation was given to you correctly, so it can sometimes require a little bit of math. We'll discover the math trick in our next video.